Hi everyone. In this video, we're going to be taking a look at more stuff with regards to budget constraints. In particular, this one is going to be focused on budget constraint transformations. Okay. Now what I mean by this is let's start off with some example numbers, but now let's switch them around a little bit and see what happens to the budget constraint graphically. Like what does the new budget constraint look like when we swap around some of the numbers that we used from before. So here I'm just going to save up on time, I'm going to copy and paste the numbers that we used from before for Carol's budget constraint right here. So I had this copied from before, just pasted that right in here. So as you recall from our example, it says that Carol runs a business with $60 budget for office supplies, where the price of sticky notes costs $1 per pack, and copy paper costs $10 per stack of copy paper. So let's start with what happens if instead of this being $60 budget, what if we only had a $50 budget? So, let's go ahead and analyze this in the same way that we did when we first worked with these numbers. We first calculate the max amount of sticky notes that she can buy on her budget and the max amount of copy paper that she can buy on her budget. So the max amount of sticky notes that she can buy is her $50 budget divided by the $1 per pack of sticky notes. So that means, oops, not dollar sign, but 50 packs of sticky notes. Then for the max number of copy paper, we take the $50 budget, divide by the $10 per stack. That means, of course, she can afford 5 stacks of copy paper, right? So let's draw this out on a graph. So here for just the sake of brevity for the video, I went ahead and copied the budget constraint that we had from part 1 of the video series on budget constraints. So this is the same graph that we had from before, calculating Kel's budget constraint with a $60 budget. Okay, so I just copied that, put that here. But what I want to do is now we're working with a different budget size, right? So instead of $60, we are working with a budget of only $50. So what I'll do is I will pick a different color. Let's try red here. So I'm going to pick the red color, and then I will draw the budget constraint if she only has $50 instead. And this is pretty easy. We already know how to do this basically, right? Since we did this from before with the $60 budget. But basically, we start with the most extreme points, like the end points of our graph. So if she spends all of her money on sticky notes, then as we calculated, the maximum amount that she can buy is 50, which is here, right? And then if she spends her budget entirely on copy paper, then that would be right here, right? 5 stacks of copy paper. And then to represent all the other possible combinations of the amount of sticky notes and copy paper that she might buy, I will just draw a line to connect those 2 points, and there we go. Those are all the other possible combinations, right? So we see as a result, of course, she can afford fewer sticky notes and copy paper as you would expect when she has a smaller budget. And the way that we um, show that is simply to draw a new line closer to the origin, right? So right here is the origin. That's where the two axes meet, where the x axis crosses the y-axis. And we just shift the line inward towards the axis, where it's a parallel shift. So, the slope of this line, of the black line, is the same as the slope of the red line here, right? That hasn't changed. The only thing that's changed is that we slide it or shift it inward towards the origin. And that's what that would look like if Carol's budget became $50 instead of 60, if it becomes smaller, right? And of course, if it becomes smaller than 50, then we would just shift it even further inward. But what if her budget was instead bigger? So here, again, for the sake of brevity, for the video, I'm just going to copy paste the information we had from before. There we go. But now I will get rid of this, and instead of a $50 budget, let's go with a $70 budget. So I am getting rid of that 5, putting in a 7. If you need to, by the way, feel free to pause the video and catch up so you can like draw the rest of the stuff if you need. But again, just for the sake of brevity for the video, I am going to keep going. So in this case, max number of sticky notes that she can buy with a $70 budget. It's quite simple. That's just the $70 budget divided by the $1 per pack of sticky notes. So 70 packs. And then max number of copy paper that she can buy is the $70 budget divided by the $10 per stack of copy paper. So of course that just becomes 7, right? So what I'll do is go back up here to this graph and draw that in. Well, we know that if she spends all of her budget on sticky notes, then she can afford 70. Here I'll draw this new budget line in green. Then of course that means I should be somewhere above 60. I'll just put it up here. Right, it doesn't have to be necessarily to scale. I'm not drawing it to scale. I'm not going to worry about drawing it to scale. And you won't need to worry about drawing it to scale either when you were drawing this kind of stuff either. But just so you know, that's not going to be drawn to scale, and that's fine. And if she spends her entire budget on copy paper, well, then she can afford 7 stacks of copy paper. So then to represent all the other possible combinations of sticky notes and copy paper that she can buy with a $70 budget, there we are. I'll just draw the line to connect those 2 points. So here I'll just write green, for my notes, $70 budget. Then black, $60 budget. And then finally in the red, this is with a $50 budget. But I wanted to show you this all on the same graph, what the different size budgets look like, so you can see that it's a very simple way to represent a change in the budget on our graph, right? Very simple. All you have to do is shift the line either inward towards the origin or outward, depending on what is happening to our budget, right? As we can very clearly see, if our budget is getting smaller, then we just shift the line inward. and it's a parallel shift, right? So again, the slope of the red line is the same as the slope of the black line. We just shift it closer to the origin to represent the smaller budget. And then, as you probably had guessed, if we got a bigger budget, say $70 here, then we just shift that line outward, as we see here in the green. And again, that is a parallel shift. The slope is the same as the one in the black line and the one in the red line. Right, so the slope is the same. It's just a parallel shift outward, away from the origin. So very simple series of transformations here. Now, you might ask, well, why is it that the line of the budget constraint doesn't get a different slope? Why doesn't the slope change? That is because, as we discussed from before, the opportunity cost is what determines the slope of the line, the trade-off between buying one good versus buying the other good, right? So even though when we scroll down here, it says Kale has a $70 budget to buy office supplies with, the trade-off of buying a stack of copy paper is still the same as it was before. It's the same no matter whether she has a $70 budget. It's the same whether she has a $50 budget. And that is because if she buys a stack of copy paper, that costs $10. And that means that the opportunity cost is 10 packs of sticky notes since it only costs $1 a piece. So if she spends the $10 on copy paper, that's $10 she could have used instead to buy sticky notes with, but she didn't, right? So because that opportunity cost is still the same, right? The price of copy paper is still $10 and the price of sticky notes is still $1, so that opportunity cost, the trade-off there is the same. Then changing her total budget around will not affect the slope of the budget constraint. That's why these are parallel lines. The green line, the black line, and the red line are all parallel to each other. So then, what will happen if we change one of the prices around instead of the budget? So let's actually work with that now. Let's check to find out what happens if I change not her budget, but the actual price of one of these two goods. So I'll scroll down here, and again, I'm just going to paste in this bit here just to save on time. If you want to pause the video, then go ahead and do that here to give you more time to copy this down. So I'll be going back to the original $60 line though, the $60 budget. But what I will do is, what if we, instead of saying it's $1 per pack of sticky notes, what if I said it was $2? Right? But everything else is the same, $60 budget, $10 for a stack of copy paper, but now the price of sticky notes has doubled to $2. Well, let's analyze this in the same way we did before. Max number of sticky notes. That she can buy is her $60 budget divided by now $2 per pack, so she can now afford 30. And max number of copy paper that she can buy is the $60 divided by 10, so that just becomes 6 stacks. Then what I did here, again, copy pasted the graph from before, the basic graph that we started with in the part 1 video. But now I am going to draw this new line for the budget constraint. using these numbers instead when the price of sticky notes has doubled. So the price of sticky notes has doubled to such that she can only buy 30 of them if she spends her entire budget there. So that would be about here, right? About halfway between the origin and the 60 mark on the y-axis for sticky notes. But she can still afford 6 stacks of copy paper, so I would still be using this point right here for my other endpoint on the x-axis. So I just need to draw a straight line connecting these 2 points. And that becomes our budget constraint when the price of sticky notes has gone down to $30. So the main thing to note here is note how this point over here on the right hand side is the same as before, but on the y-axis the line has pivoted inward, right? It's pivoted towards the origin because it connects lower on the y-axis compared to before. Now here we can see clearly this cannot be a parallel line because the slope of this line is now much shallower. And just to help prove that that is the case, let's go ahead and calculate the slope of these two lines. Now before, the way that we calculated the slope was writing out the budget constraint and then changing it to y equals mx plus b form. But remember that in general, for a straight line, to calculate a slope, you can calculate it by simply taking the rise over the run, right? If you recall from your math classes and such like that. So what this basically means is we have to take 2 points on the line and just calculate the difference in the y coordinates versus and divide that by the difference in the x coordinates, right? So the way that we would write that out is y2 minus y1. That is, we take 2 points on the graph. We take the y value of the first point minus that from the y value of the second point, right? And then we divide that by x2 minus x1, meaning we take the difference in the x values of those 2 points as well. So let's go ahead and do this for our black and blue lines here. So for the black line, I'll be writing in black ink here. So the way that we would do that is, well, let's just pick this as our y2 up here, this point up here, and this down here as our x2 as our second point, right? So point 1 and point 2. So here our y2 would be 60, right? Because it's 60 high, like vertically. The value of this is 60 because it's, up here, right? And then we subtract from that the y value of the second point, which is down here, right? So this, of course, has y value of 0 because it's on the x-axis. So in terms of the height, it's at 0, right? The origin here would be 0, 0, of course, right? So that'd be 60 minus 0. And then we divide that by the x values of these two coordinates. So remember, this was our first point. So this is going to be an x value of 0 because, again, it's on the y-axis. So it should be a value of 0 for the x coordinate. Then we need to take the x value here of our second point, which has to be 6, because we're measuring it horizontally from, the origin. So, of course, that has to be 6, as it says right here. So what we get is 60 divided by minus 6. Slope is minus 10, which is what we calculated before in part 1 of the video, right? Now, let's go ahead and do this for the blue line as well. I'll just write off to the side here. So the slope here will do the same thing, but of course we have to use points on the blue line. So here will be my first point on the y-axis, and then down here will be the second point on the on the x-axis. Sorry. So on the x-axis, this is my second point, and this is my first point, the point that is on the y-axis. So the slope here will then become 30 minus 0, because we're taking the y values. So the y value of this point right here is 30, right? Because it's 30 high. And then the y value here of this point would be 0 because it's 0 high, right? It's directly on the axis. Then for the second point, sorry, for the x coordinates, this would look like 0 for this point here, right? Because it's horizontally on the same as the origin. And then for the second point, it'd be 6, right? Because it's over here. So this means that we get a slope of 30 divided by minus 6, which just becomes minus 5. So that's how we prove that these two lines aren't parallel, because as well, we can see the slopes are different, so they can't be parallel, right? Remember that any two lines on a graph have to intersect at some point. Any two straight lines, I should say. Any two straight lines have to intersect if they don't have the same slope. And we can see, of course, that happens right here on the x-axis. This is where those two lines cross each other, the black and blue lines. So that's what happens when the price of sticky notes increases, is that the line pivots inward along the y-axis, right? But now let's see what happens to the budget line if instead of the price of sticky notes going up, what if it goes down? So here I have the same numbers from before, but I will just get rid of this bit right here where it says it's $2 per pack, and then I will change it to what if the price of sticky notes actually goes down from $1 per pack down to 50 cents per pack. So 0.50, 50 cents per pack. Then let's do the same analysis we did from before. Max number sticky notes she can buy is, she has a $60 budget, divided by 50 cents per pack. She can buy 120 packs of sticky notes, right? Then max number of copy paper that she can buy with her $60 budget is her $60 divided by $10 per stack, and that just becomes 6 stacks of copy paper, right? So let's scroll up, and here let's see if I can get another color. Let's do, is a highlighter? Yeah, that's fine. Let's actually swap this to purple. Okay. So then drawing that on this graph, of course, she can now afford 120 sticky notes if she spends all of her budget on just sticky notes. So that would be somewhere up here. So I'm just going to mark it up here, mark that 120. But if she spends her entire budget just on copy paper, she can still only buy 6 stacks. So the other end point of the budget line should be down here. Then to represent all the other possible combinations, let's just draw the line and connect these 2 points down here. So as we can see here, the slope of this line is going to be different compared to these other 2 lines, the black and blue lines. And to prove that, let's do the same thing. The slope So slope here should be 120 minus 0 divided by 0 minus 6. So that should be 120 divided by minus 6. That, of course, should end up being a slope of minus 20. So the main takeaways here then are, of course, when the price of sticky notes changes, the slope of the line changes. And that is because the opportunity cost of buying each one of these becomes different compared to before, right? Remember that the slope represents the opportunity cost of buying 1 unit of the good that is on the x-axis. So in this case, copy paper. So when the price was $2 for sticky notes and $10 per copy paper, that means that if Carol buys 1 stack of copy paper, that $10 could have been used instead to buy 5 packs of sticky notes, right? Because 2 times 5 is 10. And that's what we see here in the blue line, the slope of the blue line, right? It's 5 to represent that when she buys 1 stack of copy paper, that could have been used instead to buy 5 packs of sticky notes. Then, when the price of that changed to 50 cents per pack of sticky notes, then that $10 that she uses to buy 1 stack of copy paper could instead be used to buy 20 packs of sticky notes, right? Because 20 times 0.5 becomes 10. And that's what we see here in the slope as well, right? So the way that is shown on the graph is by pivoting the budget constraint line either up or down, either inward or outward along the y-axis. It pivots inward when the price of sticky notes went up because sticky notes is here on the y-axis. And then when the price of sticky notes goes down, then it pivots outward. So then that represents, of course, that you can buy more sticky notes compared to before. So here, copy pasted another version of the graph. If the price of copy paper went up, then it would just look like this in the blue line, and here in the purple is what it would look like if the price of copy notes, copy paper went up. And let me get rid of that because because WhatsApp is being really obnoxious. Hey, 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 come on, come on. Mouse, come on, come on. Hey, mouse, stop! Mouse, fuck off. Okay, so that's what happens if the price of sticky notes changes. Well, what happens if the price of copy paper changes? Basically, the line will pivot kind of like what we see here, except instead of pivoting on the y-axis, it will pivot along the x-axis instead. So here, I'll go ahead and quickly show you what that looks like, but instead of any using specific numbers, I'll just keep it general. So down here, I have another version of the graph, right, with the original $60 budget line and using the original prices. Well, here in the blue, I'll go ahead and mark if price of copy paper goes up. So price of copy paper, if that goes up, then instead what that looks like is like this. Assuming the price of sticky notes stays the same, that is, then it will just be a steeper line. So it pivots inward on the x-axis, right? Because there's the x-axis, the line is now pivoting inward. It starts off on the same point on the y-axis, it just pivots inward, so it's a steeper line. Then if the price of copy paper decreases, then it's just the opposite. So it starts off right here, same as before, but now it's a shallower line. Because now, of course, if the price of copy paper decreases, Carol can buy more compared to before, so the line pivots outward to show that she can buy more compared to before. But yeah, that is going to be it for this video for budget constraint transformations. Um, and I will see you in the next one.